So in this video we're going to talk about classes and objects. And we're going to be talking about classes and objects all session long. In fact, as long as you program Java, you're going to be talking about classes and objects, because classes and objects are the foundation of any object-oriented programming language. And Java is an object-oriented programming language. So when we write any program, all of the code that we write will be contained in a class. And then when we run that program, there's going to be objects that are created from those classes that interact with each other. So what you can think of is that a class is like a template, and when we create an object, we take a copy of that class and that becomes the object. So we can create multiple objects or instances from a class. And I'm going to use those words interchangeably. Some people will call them objects, other people will call them instances. I'll use those interchangeably. But when we have a class, we use that as the template to create our object or to create our instance of that class. So in the last example, we used a program in BlueJ called the ticket machine, or the better ticket machine. So you can see here, ticket machine here, anything in this window is a class. And as we had a look at in the last video, if I double click on this class, it shows me the code that is for the class. So this is a class. Now, when we want to create an object in BlueJ, we right click on the class. We select the constructor here at the top, and we'll talk more about what constructors do in a later lesson. And as we talked about before, when I run the constructor on the ticket machine class, it requires an int. So I'm going to pass it a parameter of 50. Now I've just created an object. This is an object of the ticket machine class. I can create a second one here, and I will pass this an int of 100, and I'm going to call it my ticket. So now I have a second object of type ticket machine. So notice I can create multiple objects from this class, and I can create as many as I want. So coming back to the slide here, a class describes what the object can do. We can create multiple instances or objects from a class like I've just shown you. And objects have state that is represented by storing values in their fields or their variables. So let's have a look at that. So if I look at the code for ticket machine, at the top of the class, there are some variables. This here is a comment. Anything that starts with 2 forward slashes is a comment. It's not code. It's for us to write notes for ourselves or someone else when they're going to be looking at the code. So we call these variables at the top of the class either fields or instance variables. So objects have state that is represented by storing values in fields or instance variables. So when we create objects, let me bring both of these up. As I said, the class is a template. When we create an object, you can think of it as taking a copy of that class. So it gets a copy of everything. So this object here, ticket mar2, and this object here, my ticket, both have their own instance variables. This one here has an instance variable called price, which is a type int, and this one here also has an instance variable called price that is a type int. So we call that the object state. The object state is stored in these instance variables. That means I can set a price for this one, and I can set a price for this one. I can set a balance for this one, and I can set a balance for this one. I can set a total for this one, and I can set a total for this one. Now this code here is for a ticket machine. So we can see the price is going to store the price of a ticket from this machine. The balance is going to store the amount of money entered by a customer so far. and the total is going to store the total of money collected by this machine. So this object here could have a different total than this object, and this object here could have a different price than this object. And if I make a new one, so new ticket machine, I will give this 200 and I will leave it called ticket mar3. This one here has its own copy of these variables. Remember, every time we create an object, you can think of it as taking a copy of this class, and this is the template used to create these objects. So they're all going to have their own state. They're all going to have their own instance variables. So objects can communicate with each other by calling each other's methods. And an object usually does something if one of its methods is invoked. So if we scroll down further, let's bring up this. We can see the first thing here is called a constructor. We'll talk about that in later classes, but that's actually what we're calling when we create an object. See, new ticket machine int cost, ticket machine int cost. That's the constructor. That's what creates the object. And we'll talk about that in a later lesson. Scrolling down further, all of these things here are called methods. And they all do something when we call them. So they can communicate with each other. So one object can call another object's methods to pass data or return data. But an object usually does something if one of its methods is called. Now we can call the methods on one of these objects by right-clicking on it. So let's right-click on this ticket machine and let's call this method getBalance. GetBalance 0. So it returns something. We can see it returns something because, and we can see it returns 0. It returns balance. And balance is one of its fields or instance variables. I can call the next one here insert money. So insert money, we can see insert money requires an int, and we know that here if we look at the method insert money, it requires an int. So let's insert something. Let's insert 30. And we know from the previous video that an int is a whole number. Alright, now let's get the balance on this one. Balance is 30. Have a look at this. If I call getBalance on the second object though, its balance is 0. Balance on the first one is 30. So in the second one now, I'm going to insert some money. I'll insert 100. Now if I call getBalance on this one, its balance is 100. If we look at the first one again, its balance is still 30. That's because, as we said, objects have state that is represented by storing values in fields or variables. So all of these objects here have their own copy of these variables, and they have their own copy of these methods. Now moving on to the next slide, we're going to talk about naming of classes and objects. Now this is really important. In Java, there are very strict naming conventions. Now your code will still run if you don't follow these, but you will lose marks in your assignment. And the reason is that Java recommend how you name everything when you write code. And no matter where you go, who you work for when you finish this course, everybody will follow the same naming conventions. So class names use upper camel case, object names use lower camel case. What that means, upper camel case means the start of every word is uppercase. There are no spaces. There are no underscores. Lower camel case means the first letter of the first word is lowercase, then the rest of the words are uppercase. So class names use upper camel case. Object names use lower camel case. Classes and object names should not start with a number, a special character, or have spaces in their names. So if we go back here, we can see ticket machine is upper camel case, capital T for ticket, capital M for machine. But you have a look when I create an object. I'll call this one some object. I can call it whatever I want, but it's got to be lower camel case We can't put a number to start it. We should not start it with a number, a special character, or have spaces. So coming back here, I should not start it with a number like that. You can see, whoop, that is not allowed. We can't have spaces. If I tried to do that, it would say must be a Java identifier. And I can't have special characters. So they are the naming conventions for classes and objects.